Hi, today we are going to talk about systems of linear inequalities. Okay, so a system of linear inequalities is just like a system of equations, except there's going to be an entire shaded region that makes both inequalities true. But we're just going to have two inequalities on the same graph, and then we're going to find the overlapping region, and that region is going to make both inequalities true. So find the solution to y is greater than 2x minus 3 and y is less than or equal to negative x plus 1. Okay, so the first thing you're going to do is you are going to graph the first inequality and you're going to shade lightly. Okay, so in order to graph, we need to sketch our own graph for our notes. Okay, so to graph the first inequality, y is greater than 2x minus 3. So we're going to graph our y-intercept, which is negative 3. And then our slope is a positive 2. So I'm going to go up 2 and to the right 1, up 2 and to the right 1, up 2 and to the right 1. So you want to graph all the points that you can fit on the graph. And y is greater than, so it is a dashed line because it's not equal to. And since it's greater than, where are the values greater than this line? Above the line. So we're going to lightly shade. Next, we are going to graph the second inequality. And we're going to shade lightly. So our second inequality, first we need to graph our y-intercept, which is positive 1. Our slope is negative 1. So negative 1, our line's going down, and our rise and run are both 1. So negative 1 over 1. I'm going to go down 1 and to the right 1. Down 1 and to the right 1. Down 1 and to the right 1. Up 1, right 1. Up 1, up 1, left 1. Up 1, left 1. And y is less than or equal to. So since it's equal to, the points on the line will make this inequality true. So we show that with a solid line. And y is less than, so we need to shade below the line, which is going to be this region right here. So notice the points don't cross, the lines don't cross at an exact point, and that's totally fine with inequalities, okay? You're only looking for that exact point when you're doing systems of equations, not when we have inequalities. So inequalities, we are looking for the region where the shading overlaps. So if you look here, this region only makes the red line, the red inequality true, okay? So that was our first inequality, okay? This region down here is only shaded blue. So this region, if you pick a point in here, it will only make the second inequality true. We are looking for the solution that makes both inequalities true, which is this region right here. And so what we're going to do to show that is we are going to darkly shade the overlapping area. This region is the solution that makes both inequalities true. Okay, so that is this region right here where it's shaded blue and red. All of these points below the blue line and above the red line, if you pick any of those points, it's going to make the inequalities both true. So let's check our answer. So remember, it has to make both of them true. So an easy one is 0, 0, lies in the solution. So we use 0, 0, x is 0, y is 0. We're going to test it, and y is greater than 2x minus 3, and y is less than or equal to negative x plus 1. So we have 0 is greater than 2 times 0 minus 3. 0 is greater than negative 3. Yes, 0 is greater than negative 3. And is 0 less than or equal to negative 0 plus 1? So it's 0 less than or equal to negative 0 is just 0. 0 plus 1 is 1. Is 0 less than or equal to 1? Yes, it is. So we know that we found the correct region for our solution. Okay, let's go ahead and look at your assignment, system of linear inequalities. So we're going to sketch the solution and then pick one point and show that it makes both inequalities true. So y is less than or equal to x minus 2. So we graph our y-intercept first, negative 2. Our slope is a positive 1. So our line's going up. So go up 1, right 1, up 1, right 1. Down 1, left 1. And y is less than or equal to. So we know it is a solid line. So feel free to use your notes on graphing linear inequalities if you're struggling with the solid or dashed line and where to shade. And then y is less than. So we're going to shade below the line because it is less than. So below the line is right here. Then let's graph our second inequality. Y is greater than or equal to negative 3x plus 2. So our y-intercept is positive 2. Our slope is negative 3 over 1, which means our line is going down. So if I go down 1, 2, 3, I have to go to the right 1. Down 1, 2, 3, right 1. I could also go up 1, 2, 3, left 1. Just make sure your line's going down from left to right since your slope is negative. Y is greater than or equal to. So since it is equal to, it is a solid line. And y is greater than, so you're going to shade above the line. Is this above the line? No, that's below my pen. So I need to shade above my pen. And then remember, you want to now darkly shade the overlapping area. So where is it shaded red and green? Right here, below this red and above this green. So this area right here. That region right there is the solution. And let's prove it. So we're going to pick a point. I'm going to pick 3, 0. Let's check point 3, 0 to make sure. So we have y is less than or equal to x minus 2, and y is greater than or equal to negative 3x plus 2. So x is 3, y is 0. So we plug in 0 for y. 3 for x. Is 0 less than or equal to 1? Yes. 0 is less than 1. If you have 0 cookies, you have less than Leslie, who has 1 cookie, right? Okay, and then y is greater than negative 3x plus 2. Plug in 0 for y. Is that greater than or equal to negative 3 times x, which is 3, plus 2. Negative 3 times 3 is negative 9. Negative 9 plus 2 is negative 7. And is 0 greater than or equal to negative 7? Yes. 0 is greater than negative 7. So we know that this shaded region is our solution. Okay, go ahead and graph both lines and then darkly shade the overlapping region to show the solution, and then pick a point in there and check it.